I'm Ayse Bilgin from Macquarie University in Sydney, Australia. I'm teaching a really large first-year statistics unit with more than 1,000 students in each semester. So COVID-19 certainly brought some opportunities to streamline the assessment for these students. Because it's quite large unit and because Australia has lots of international students, there was problems like students scattered all around the world. I have students in China, Myanmar, France, US, all over the world, and they all have different COVID-19 restrictions and absolutely travel restrictions. No one can come into Australia with Prime Minister's approval. So it's a big deal, and to be able to deal with these things, we couldn't use traditional exams. It was close to impossible logistically to do that. So what we have done is a solution that required timely, rich feedback, eliminate logistic problems, discourage academic dishonesty, and keep student voice in the assessment while achieving consistency of marking. I've created online non-invigilated assessments within our learning management system. We are using Moodle, and the questions there could be entering a numerical value based on a given scenario after making calculations, selecting an option, multiple choice questions for a given scenario. I'm going to talk about mainly here the questions that require downloading a data set, analyzing the data, then either entering a numerical value obtained from the solutions or selecting an option from a set of options based on the calculated numbers from that data sets. These questions are created using our exam package. I also had questions that required typing an answer for a given scenario. These ones are manually marked, but all of the above are marked automatically. Here's an example for manual online marking. These questions, they all needed to be created within learning management system, and the answers had to be entered one by one, and then marking criteria had to be entered for markers to be able to mark. So the number of options that can be created is limited with the time of the academic and also imagination of the academic, I suppose. When these open-ended questions are given the students randomly, I ask 2 questions for each student, and I had more than 50 versions altogether for 2 questions. With 1,000 students taking the exam, you can see here is interpretation of a table 2 question was given to 60 students. They are all marked. Now I'm going to present the results in a few days to my department. Chi-square assumptions related open-ended questions was taken by 65, and they're randomly allocated to students. So I'm not going to talk about these open-ended questions, but I'm going to talk more in detail about the questions that require downloading and analyzing data. Okay, so I have created a scenario, and in that scenario, you can see that there's a number here, 27 countries. This number is randomly created. I'll give you my R script, how I created them. And based on the randomly created groups, I also written out an Excel file for each different version of this question. So the file name is the same. All the students download the same named file, but the data within that files are different. So I pose the question, and then I have a few questions at the top, which I'm not showing you here, but then I ask them, assume any relevant assumptions for the test that you have chosen that's most suitable for this question. They are met, and then answer the following questions. So absolute value of the test statistics equal to, I require them to enter it in 3 decimal places, and degrees of freedom, and p-value whether it was larger than 0.05. And then I asked them a conclusion based on their calculation. And you can see that from that top-down menu, they will see these answers, A, B, C. So they have to decide which one is the right answer for all their solutions. So how I created this question is I randomly create 2 groups and 2 normal distributions. And then because this was a too simple question, I also gave them some graphs about the difference between 2 groups. So they had to choose whether it's an independent too simple t-test or whether it was a paired t-test. What I've actually had in the final exam, you will see soon, is same file name. In one case, they needed to do paired t-test. In the other one, they needed to do 2 sample t-tests, and students randomly got that. Some students got the independent 2 sample t-test, some students got the paired t-test. If they were trying to cheat, it would be very obvious and they will get the wrong answers. And you can see that the data is written out here as an Excel file. This is still in R. And then here's how I created the scenario. You can see here that number of countries is a random variable here. And for each student, it'll be different. And then you can see here at the bottom how I've created the graphs that I displayed in the question. These graphs is based on the data set they receive. You can see here the graph for the differences. So if it's a paired t-test, we look at the differences are normally distributed or not. And then in R, at the bottom of my R script, I say this question will go to final exam 2021 semester 1 in a subset called too simple or paired. And then this will be under the too simple, and that is the 4th scenario. So that's what I do in R. And then taking this script using our exam package, I can actually, this is the script created, I can actually easily create 150 different versions of it, or even 500. But you can see I've created the t-test and paired t-test R scripts, and I'm running here and creating 150 different versions of each of those. So how they look in my learning management system, which is Moodle. If we look at the t-test, too simple or paired, you can see I've only used the scenario 3 for paired t-test, which I had 120 questions in there. For too simple t-test, I had 2 different scenarios, one with 70 questions, one with 50 questions. In my final exam, I also asked students to upload their Excel files where they needed to download a data set and analyze the file. So I could actually check if there was any suspicion of plagiarism, academic dishonesty. I could actually check the Excel files to see whether a student actually did the job. Students found it easy to take online assessments, although they couldn't do it anytime. They were a set time. Feedback provided to them, given them opportunities to learn from their mistakes. They had a practice version of it with a different scenario. No exam paper was lost. No academic dishonesty was identified. Although you can find my exam questions, some of them in Check or Course Hero. Marking completed in much shorter time, and the consistency of marking was ensured for the open-ended questions. Assessment of students' learning was as good as before COVID-19. Great distributions, and the failure rates were very similar. Are we there yet? We're never there. Improve the quality of questions, clarity and language, because some of the students thought there were mistakes in the exam because questions could have been interpreted this way or that way. Increase the variety of questions, increase the number of alternatives for randomization, and improve assessment so that students continue learning. Assessment should not be the end, but it should be the continuation of learning. Thank you for listening.